Welcome to another exciting educational video brought to you by Observation Concepts Academy. So today we'll be looking at WAEC maths questions on indices and logarithm. If you are yet to subscribe to our channel, kindly subscribe to our channel, share the videos with your friends so that they can know what we are doing. Sit tight today, promises to be an exciting ride on the indices and logarithm. So we dive in. First question here is on indices, fractional powers. Now I have this question, say evaluate, open bracket, 4 raised to the power 1 over 2 plus 125 raised to the power 1 over 3 all square. Agree with me that there are two terms inside this bracket, this term and this term. So I can individually uh, solve for 4 raised to the power half. This translates into square root of 4 because anything raised to power uh, fraction, the denominator determines the kind of roots. The denominator for this exponent is 2, and it tells us that it's going to be a square root. So the square root of 4 is actually 2. Again, if you look at the fractional power, the denominator tells us the kind of root, and the numerator tells us the power that the whole expression is raised to. So this is actually raised to power 1, technically speaking. So square root of 4 is 2. And for the 125 raised to power 1 over 3, again, I have a fractional exponent. The denominator, or 3, is telling us that this is a cube root of 125 all raised to power 1, all raised to power 1. Okay, 125 all raised to power 1. And this cube root will give us 5. So in effect, I have that this gives us 2 and this gives us 5. So it's actually 2 plus 5 all raised to power 2 plus 5 is 7 raised to power 2, which gives us 49. Okay, so that is it. All right. So the next question is indices, laws of indices. So I have this on the screen, 3 raised to the power n minus 1 times 27 raised to the power n plus 1 all over 81 raised to the power n. Now, if you look at this, you see that 3 here and 27 here and 81 here can be expressed as the base 3 raised to the power whatever power you can get to return back the value. So for 27, I know we can say that it is expressed as 3 raised to the power 3 because 3 times 3 is 9 and 9 times 3 is 27, and 81 can be expressed as 3 raised to the power 4, right? So I can introduce this and this into this expression I have here. Okay, so it will now be 3 raised to the power n minus 1 times, so instead of having 27, I'll write 3 raised to the power 3, open bracket, n plus 1, and all over, writing 81, I'll write 3 raised to the power 4, uh, n. Okay, so you can see I have the same base, 3 here, 3 here, and 3 here. And between the numerator, you have the operation multiplication between them. And between the numerator and the denominator, you have the division operation. So this can be written as 3 raised to the power n minus 1. Because this is multiplication, you have dots 3 raised to the power 3 into n plus 1. And this is division. So it will now be divided by 3 raised to the power 4n. Okay, so this, because these are all the same, they are all the same base. So for multiplication, I add the powers. For division, I subtract the powers. So I just take one base, 3, then I add the powers for multiplication, n minus 1 plus, because this is multiplication here. So the powers are the powers n minus 1, then plus 3n 3n plus 3, because I'll have to open this bracket. Open bracket. 3 into 3 times n is 3n, and 3 times 1 is 3. Then the division will make me subtract the power. So I have all this as power. So I can simplify these powers. Let me take this to this side. So this translates to 3 raised to power. So I have n correct items, n plus 3n minus 4n. I've collected all the n terms, and this constant term minus 1 plus 3. So 3n, so n plus 3n will give us 4n. So 3 raised to the power 4n minus 4n, then minus 1 plus 3 will give us plus 2, right? So this will cancel this. So I will have 3 raised to the power 2, which is 9. So 9 is the answer. 9 is the answer. So I will take it off so that you can see the presentation for this. Take all this off. So 9 is the answer, but let me show you the neater presentation for this particular problem. Okay, so by way of explanation, convert all base to 3. Okay, you have this expression, you have this, you have this, and then you have 9. Okay, so move on to question 3, standard form. So this is standard form. It says express 0.009 in standard form. So standard form is in the form a times 10 raised to the power n. So where a is the second digit. So I'll be starting with 9, and n is the decimal movement to the leading significant figure. So if I move this to the right, that is 1, 2, 3 to the right, means I'm going to be having minus 3 position. So this will now be 9 times 10 raised to the power. So this again is 1, 2, 3 movement minus 3. This is the standard form for this particular expression. All right. So again, standard form 0.009 over 0.12 in standard form. So I'll move the decimal points. So I'll have 9 over 12. So in decimal, it's going to be 0.75. And of course, by the time you move decimal points, 1 point to the right. So the n will become minus 1. So 7.5 times 10 minus 1. Okay, so that's the answer. So, but when you are moving to the left, if for instance I have 7,500 as standard form, so my decimal point is after the 0. So I move my points 1, position 1, 2, 3, where I have the leading significant figure. So I have 7.5 times 10 to the power 3. So that's how you interpret if it is moving from right to left. So it's positive. The exponent for the 10 is positive. Okay, logarithm. So I have log 10 of 1 over 100. You know that this 1 over 100 can be expressed as 100 raised to the power minus 1. And again, if I put it in decimal form, in exponent form, it will be 10 raised to the power minus 2. So this is for the 1 over 100. So I can say log 10 to the power minus 2 to base 10. This minus 2 will come down here. That's the rule of logarithm. So it's minus 2 log 10 to base 10. So anything base anything, the same thing is 1. That is, i.e., log 10 to base 10 is equals to 1 according to the rule. So this now becomes minus 2 times 1, which is minus 2. So that's the answer. Okay. So move on to the next question. So we have log x to base 4 is equals to minus 3. Again, we convert to the exponential form. So you have 4 is power 3. So we see when this 4 goes up to join this. So I have x is equals to 4 is power minus 3. That's a rule of logarithm. So at this point, x can now be expressed by simplifying this. So it's something as 1 over 4 is power 3. And 4 is power 3 is 64. That's the answer. So logarithmic laws. So I have log 4 plus log 25. And the law we're going to be using is if we have log A plus log B, same thing as log AB. So if the a positive operation, a plus operation is involved, then you have log of the you multiply both terms, right? As we're seeing here. So we're going to go ahead and apply that to this particular question. Log 4 times 25 is log 100. And log 100 is something as 2 because log 100 to base 10. So by the way, anytime you see log without a base 10 in it, it means that this is base 10. We don't normally write base 10. You can write it, but it's not, it's, if you don't see it there, you know it's base 10. But if it's any other one, it will be specified. If it is log 2, if it's to base 2, it will be specified. If it's to base 3, it will be specified, and so on. So, but this is log 100 to base 10, and you know that log 100 now is attempting as saying square, right, to base 10. So these two will come down. I have 2 log 10 to base 10. So 10 to base 10, all of this is 1 times 2 will give us 2, right? Okay. So this is equation of logarithm. So you see that all this is a log to base 10, log to base 10, log to base. Remember I told you if it's not specified, it means it's to base 10, right? So if you have something like this, minus in between two log expression, minus is change it to division. That is, I can write this as this log x plus 2. Because I have this as minus, I'll write a division, a line to show division, then I'll say over x plus minus 1. Then it's same thing as saying log 2, right? Okay, so this log will cancel this log, and I have x plus 2 over x minus 1 is equals to 2. All right, so I can cross multiply. So I have x plus 2 is equals to 2 into x minus 1. So I have x plus 2 is equals to 2x minus 2, opening the bracket. So collect like terms. So x minus 2x is equals to minus 2 minus 2. Then this is minus x, and this is minus 4, and x is equals to 4. So that's the answer for this one. All right. So this is logarithm tables. So use tables to evaluate this. So the first thing we'll do, we'll have read out what you have there, 5.34 times 67.4 all over 2.7. So I can individually get the log of 5.34 using log table. So this is the reading for 5.34. And for 67.4, I get the reading on the log table as this. And when you have multiplication upstairs here, the logs are going to add the logs. So I'm going to add this plus this, right? So when I add it, I'm going to get 2.5 0.562. Recall that I'm still going to get the log of this denominator, 2.7. So when I get it, this is it. So I'm subtracting that from there because uh, the there's division line. So for multiplication, I'm adding the log. Division, I'm subtracting the log, right? So I'm having 2.5562 minus 0.4314. So that will give me this. So I'm going to find the antilog of this. The antilog of this will give me 1332. 1332 is the answer. So if you use your calculator to punch, you'll be getting something close to this. But you are asked to use log table too. So if you are doing your WAEC and you're asked to use log table, you need to follow this kind of procedure to show your workings. Again, if I have log D given as 1.8732, find square root of D. So for square root, just divide this log by 2, right? That's what's going to happen here. You get the answer, then you get the antilog of this. Antilog of this. So the antilog is 0.86. All right, so we'll move on to negative powers. So if I have 16 raised to the power minus 1 times 8 raised to the power 2 all over 4 raised to the power minus 2. By the way, this expression can be written as 1 over 16 times 8 square is 64 all over 1 over 16 again, right? Okay, so this is just to let you know. So okay, but we are going through the route of the powers, going to the route of power. So this is actually 2 raised to the power 4, 2 raised to the power 4, and this is 16 to the power 4, is 2 raised to the power 3, and 4 is 2 raised to the power 2, right? Okay, let me take this off so that we can solve it using indices methods. Okay, so the next thing we'll do is to plug in these values that's into these plates, right? So where I see 16, I have 2 raised to the power 4 minus 1. So this one represents 16 raised to the power minus 1. Okay, then I also, for where I see 8, I put 2 raised to the power 3. Okay, and of course, the denominators. So I have everything in base 2. I have 2, 2, and 2 here. Okay, so you know that I can take one of the tools, add the powers for multiplication, and subtract the powers for division. So that's what we're going to do now. So if I simplify this, so I have this becomes 2 to the power minus 4, this becomes 2 to the power 6, and this becomes 2 raised to the power minus 4. So at this point, I can just take one of the two because they are all the same base. Then I will add the powers for the numerator, add the powers, and for the denominator, I subtract the powers, right? Subtract the powers. This is what it will give me. Very good. So I have 2. Okay, okay. Let me take this off so that you can see. So I have minus 4 plus 6 plus 4. That's for the powers. 3 to the power minus 2 to the power 6 about 64. Final answer. Move on to number 12. So this is a simple case of fractional equation. X to the power minus x to the power half is equal to 5. So to remove this half, just square both sides. I square this side, I square this side. That's 2 we cancel 2. So x is equal to 5 squared and x is equal to 25. 5 times 5 is 25. Okay. Next one is standard form multiplication. So it evaluates this times this. This is 3 times 10 to the power 4 and times 2 times 10 to the power 3. Now, if you check, I can do something very fast here. I have 10 to the power 3 here. I have 10 to the power 4. I can convert this one to look like this. So I rewrite it again by saying 3 times 10 to the power 1 times 10 to the power 3. That's for the first one. You know that what I've done here, I can still go back to this by simplifying these two, right? I can still go back. But I've splitted it so that I can have this one common to this one. So this is times 2 times 10 to the power 3, right? So at this point, I can lock these two together and say this is 30 times 10 to the power 3. That's the first bracket. Second bracket, 2 times 10 to the power 3. Now, if you check at this point now, I see that I have 10 to the power 3, 10 to the power 3 common. I bring out one of them, understand, factorization. Then I now have 30 times 2, right? 10 times 2 is 60, and times 10 to the power 3. So this is the answer, or I'll say I'll take it back 60, that's 6.0 and 10 to the power 4. But this 0 will have to release itself to join this one. So I have it as 6.0 times 10 to the power 4. That's the answer. Okay, we're not done yet. Just trying to, let's go back to where we were. Okay, we're still a long way. Just hold on, please. Okay, hold up. Okay, okay, okay. So this is what we just did now. All right. So next question is standard form addition. Okay. So again, I have five times 10 to the power 3 plus 2 times 10 to the power 2. Again, I see this one, 10 to the power 2 and 10 to the power 3. I can convert this to look like this. I would do in this bracket, I would say 5 times 10 times 10 to the power 2. So this one, where I'm coming from, is the same thing because these two can give me this 10 to the power 3, right? 10 to the power 3. And then plus 2 times 10 to the power 2, right? So I can collapse these two together. This is 50 times 10 to the power 2, open bracket, close bracket, plus 2 times 10 to the power 2. Right, so this is common. 10 to the power 2 is common to both times. So I'll bring that one outside. So I have 50 plus 2. Okay, 50 plus 2 is 52 times 10 to the power 2. So I can change this to decimal point. 5.2 times 10 to the power 3. That's the final answer. Okay. Okay, so laws of logarithm. Uh, log 8 minus log 2. Minus is division. So if I have log 8 is that log 8 to base 10. 8 to base 10 minus log 2 to base 10. So just take the same base and divide the numbers here. Divide it. So log divided by 2 is 4 to base 10. So this is the answer. We can even express this in terms of 2. You can ignore the base 10, just ignore the base 10. If you don't see base 10 written there, you know it's base 10, right? So log 4 is same thing as 2 raised to the power 2. It can be 2 log 2. So it depends on what you see in the option. If you are doing MCQ, that's multi-choice questions, this and this are the same thing, right? Okay. Right. So logarithm equation, log x is equals to 3. Log x is equals to 3. So same thing as saying 10 raised to the power 3. So like I said, when you say have log to a base, the base is not specified. You know it's 10. It's not, we're not seeing 10 there, but it's 10. It's equals to 3. So this is x. X 10 will go up here, 10 raised to the power 3. So x is equals to um 1000. Okay, so if I put it there, it's the same thing as saying log 1000 to base 10 will give you 3. Give you 3. That can be easily proven. All right. So the final answer is 1000 for x. Okay, so log 16, what is it? Log 16 is same thing as 16 is same thing as saying 2 to the power 4, right? Okay, so by the time you put it there, it's the same thing as saying 4 log 2. And the log 2 in terms of four-figure table is 0.3010 times 4 will give you 1.204. So this is how this is solved. Final answer 1.204. Okay, so I have this again, advanced logarithmic equation. So this side of the equation, uh, you have this log, and this plus. What I say is that when you see a plus there, it becomes a multiplication. So same thing as saying log, then you multiply this one by this one, and to give us log 8. Log 8. So you have log here cancels out. So it's x minus 1, x plus 3 is equals to 8. So I'm going to solve this using quadratic equation form. Okay, so let me take this off and let me go back to the presentation. Okay, so the next thing we'll do is to get it in this form. Okay, so this is where we are. And then from there, we'll have the equation formed. This is the equation formed. And then it can come here and become minus 11, right? So at this point, I will use the formula method. A is 1 this point for this particular case, B is 2, and C is 11, minus 11. We're going to put them in the formula equation. Formula equation says x is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. That's what happened here. So you need to know your formula method. And the final answer is positive. This root, there are two roots, but it's the positive one that will be the answer. Okay, next question. So we evaluate using log tables, roots 45.2. So 45.2, if you use log tables, log 45.2 is already this, right? So you divide by 2. For square root, after you've gotten the log of the number, for a square root operation, just divide by 2 and get the anti-log. So it's 6.72. Exponential equation 2x 2 raised to the power x is equal to 32. Okay, and the 32 is expressed as 2 raised to the power 5. So we can put 2 raised to the power 5 where we see 32 here, right? Okay, so x is 5 already. X is 5 because if I say 2 raised to the power x is equals to 2 raised to the power 5, where this one is 32, right? They are the same base, just equate the powers. That's why you get x as 5, right? Okay, so this is simplification of indices. Again, if you check, this is 9 raised to the power x and the times 3 to the power x plus 1 all over 27 raised to the power x. All this can be expressed in base 3. So I have 3 raised to the power 2 for 9x times 3 raised to the power x plus 1. And 27 is 3 raised to the power 3, then x. Right? We'll see it here. We'll see it here. So by the time you put everything, uh, you have this, you have this, you have this. So they are the same base 3, 3, 3. So for multiplication, you add the powers, division, you subtract the powers. So we're going to see how that will play out. Take this off. We'll see how that will play out. So we're going to be dealing with the powers. And the powers, you see everything here. By the time the simplification happens, you see that 2x plus x will give us 3x. So this 3x will cancel this 3 minus 3x. And I have 1 remaining at the power, and 3 to the power 1 is 3. Okay, so this is another beautiful indices equation. 5 raised to the power 2x is equal to 125. Again, I can express 125 in terms of base 5 raised to the power you see 5 raised to the power 3. So you have this written as 5 raised to the power 2x is equals to 5 raised to the power 3. So same base can equate the power. So the power 2x is equals to 3 and x is equals to 3 over 2. That's the value of x. So the next one is standard form division. Standard form division. See this one here, I can divide them, and this one I can subtract the power. So 6 over 3 times, because they are the same 10, 10, I just take on 10, subtract the powers 5 minus 2, right? So this is 2 here 1, 3 here 1, 3 here 2. So this is 2 times 10 to the power 5 minus 2 is 3. So this is the answer. Right, standard form. So I have this standard form here. Again, I can uh, I can multiply 2 times 3 is 6. 2 times 3 is 6. Okay, 2 times 3 is 6. Then I take one of the 10 and add the power 4 plus minus 2. Then over 6 times 10 to the power 3. So this will cancel this one. And then I have 10 raised to the power 4 minus 2, then minus 3, right? Okay, so I have this and this will give me 5. 10 raised to the power 4 minus 5 will give me 10 to the power minus 1. So it is simple as saying 1 times 10 to the power minus 1. All right, so I have 2 log 3 plus log 5. Again, log 3 is expressed as log 3 square. Why? Because this will go up, become the power. That's why we have log 3 square, and log 3 square is 9. So the whole of this is now log 9. This is log 9 and plus log 5. So log 9 plus log 5 is log 45. Why? Because you multiply 9 and 5. If you have the same base and there is a plus sign, you multiply the the numbers. So it's log 45, that is the final answer. Now logarithmic equation, I have log x plus log x minus 4 is equals to 1. Okay, so it's the same base. This one at the other side, it will be log 10. Okay, so see how it's done. So I have this plus here equals to multiplication. That's why I'm having this one multiplying the whole of this uh, x open bracket x minus 4 is equals to 1. Okay, so um, log 1 to base 10 is 10. Yes, log 1 to base 10 is 10. So again, I'm going to be having quadratic equation, and I'm going to be using formula method to solve this, get the um, to get the answer. Check out our video on algebraic process and expressions where quadratic equation was fully dealt with. So from here, you get your answer. There are going to be two roots, but we normally take the positive roots for this kind of case. The two roots come from the fact that you have a positive and negative, plus or minus point, and the one root will have the plus, and the other root will have the minus. Okay, 27 says evaluate 8 to base 2, that's log 8 to base 2. Okay, itself is expressed as 2 raised to the power 3. So when I put 2 raised to the power 3 in place of 8 in the question, I get 3 is the answer. That expression is 3. Why? Because if I come here and I say log, instead of having 8, I say 2 raised to the power 3, right? Into base 2. This 3 will come down here. It will become 3 log 2 to base 2. So anything log to that number to its base, the same here. You have the number and the base is the same. It becomes 1. It resumes to 1. That's according to the law of logarithms. So it's 3 times 1, which is 3. So number 28. So multiply this using log tables. So first of all, get the log of this, the log of this, add it together, and find the antilog. So we'll go. So log 23.5, according to the log table, is 1.371, and log 42 point, sorry, log 4.62 in log table is 0.6646. So you add the two of them because we're looking at multiplication here. Add the two of them, so you get the answer as 2.0357. Then this one, you find the antilog of this, the antilog of this. When you get the antilog is 108.6. Okay, so log table division. So how to divide this again? You find the log of this with your table, find log of this with your table, subtract the two of them and find the antilog. So the log of 72.4 is this, log of 3.2 is this. You subtract the two of them, you get 1.3546. Then you get the anti-log of 1.3546, anti-log of 1.3546, getting 22.6. And finally, if I have 10 raised to the power x is equal to 250, okay, so actually it is x is equals to, sorry, take log x is equals to log 250. Why? Because this one can come under here, so it is x equals to log 250 to base 10. I told you that if we don't have anything written here, it means that it's in base 10, right? So I'm going to be getting the log of 250. There are many ways we can do this, so this is a very exciting way. First of all, 250 expressed in terms of standard form. So I see log 2.5 times 10 to the power 2 standard form. Okay, so this log outside can be acting on the log inside. So I mean in this on the values inside. So I have log 25, log 2.5, and log 10 to base log 10 to the power 2 to base 10 is actually 2. Okay, let me quickly explain this part. So if you have log, now this one is multiplying this, right? Have log 10 to the power 2 is in base 10. These two will come to be coefficient, so it will be 2 log 10 to base 10, right? 10 to base 10 is already 1. That is why I'm having this one as 2. This translates to be, if you find the log of 2.5, you get 0.3979 plus 2. You get this. So this is the approximate answer for this particular question. So I hope this video has been informative for you. I'd like to thank you for viewing. Please subscribe to our channel if you have not done so. And let this go to a friend, share to a friend, and see you in the next lesson.